Somewhere in the deep black of the Milky Way, a telescope lens clicks, capturing a flicker of light from a world that breaks every rule we thought we knew about how planets are born. What if I told you that the more we look at the stars, the more we find worlds that, by every rule of astronomy, simply should not be there? Today, we are hunting 3 impossible planets that defy our understanding of how the universe builds itself. But stay until the end, because the most unsettling world of all isn't just impossible. It's a zombie reborn from a star that already died. You start your journey hundreds of light years away, staring at a star that looks like a dying ember. This is a red dwarf, the most common type of star in our galaxy. Tiny, cool, and ultra-low mass. Because these stars are so small, our current models of planetary formation say they shouldn't have the gravitational muscle to form anything bigger than a small rocky ball. But then, we found it, a Neptune-sized giant world, a massive ball of gas and ice orbiting an ultra-low mass star that is barely a fraction of our sun's size. When a star system is born, it starts as a spinning nursery of gas and dust called a protoplanetary disk. For a tiny red dwarf, that disk should be thin and starving for material, containing barely enough bricks to build a planet like Earth. Finding a Neptune here is like trying to build a skyscraper using only the materials found in a single Lego set. Scientists now think our theories are missing a huge piece of the puzzle. Perhaps these disks are much denser than we realized, or the material accumulates much faster than we ever imagined possible. But while a planet being too big for its star is a massive scientific headache, the next world on our list had to survive a literal apocalypse just to stay in the sky. Close your eyes and imagine the end of the world. In about 5 billion years, our sun will run out of fuel and swell into a red giant, a gargantuan fireball that will expand until it swallows Mercury, Venus, and likely Earth. This is the standard death knell for stars like ours. They bloat, they burn, and then they collapse into a shriveled, glowing white dwarf. Logic says that any planet caught in that expansion should be vaporized, turned into nothing but a cloud of dust that eventually settles onto the star's surface. Yet astronomers have spotted a giant world orbiting one of these shrunken stellar corpses. It is sitting right there, dancing around a white dwarf that should have erased it from existence eons ago. How did it survive the fire? The leading theory is that this planet was a coward. It likely spent its youth in the far, frozen reaches of its system, well out of reach of the red giant's flames. Only after the star had already died and collapsed into a tiny white dwarf did the planet migrate inward, drawn by new gravitational shifts to orbit the grave of its former parent. It's a ghost world, haunting a dead star in a system where life was silenced billions of years ago. Survival is an incredible feat, but our final destination is a world that was never supposed to be born in the first place, a zombie world that exists in the heart of a radioactive nightmare. Welcome to the most dangerous neighborhood in the galaxy. You are orbiting a pulsar, a city-sized ball of neutrons that is all that remains after a massive star explodes in a supernova. This stellar corpse is spinning over 100 times every second, dragging the fabric of space-time with it and blasting beams of high-energy radiation across the universe like a frantic, lethal lighthouse. When a star goes supernova, it's the most violent event in the cosmos. The blast wave should strip away atmospheres and kick any surrounding planets deep into the interstellar void. And yet, the very first exoplanets humanity ever confirmed, way back in 1992, were found right here, orbiting a pulsar named PSR B11257+12. These aren't the original planets that were there when the star was alive. Those were long ago destroyed or cast out. Instead, these are second-generation planets, or zombies. Scientists believe they were born from the ashes of the supernova itself, as the cooling debris from the explosion fell back toward the pulsar and flattened into a new radioactive disk. They are literally made of the recycled remains of their own ancestors. You would never find life here. The pulsar's intense wind of electrons and positrons would strip your atmosphere away in an instant and bake your surface in a constant stream of X-rays. These zombie systems are staggeringly rare, but where there's one, there are almost certainly others, ticking like perfectly timed clocks in the dark. Every world we've looked at today was once called impossible by the smartest minds on Earth. We said tiny stars couldn't host giants, we said white dwarfs must be lonely, and we said nothing could exist in the wake of a supernova. But the universe doesn't care about our rules. We have already confirmed over 6,000 exoplanets, and with every new discovery, we realize that the 200 billion stars in our galaxy are hiding worlds stranger than any science fiction writer could ever conceive. There are worlds made of diamond, worlds that rain glass, and worlds that shouldn't exist, yet there they are. The question isn't whether impossible planets exist, but how many more are out there right now, waiting for us to look up and see them. If you're ready to see the universe through a different lens, hit subscribe and join us at Curious Lens.